laser communications, which would speed communications even further. He didn't elaborate on that, but it's maybe something interesting to look into. Okay, one of the things that you can see here, this is the young student whose name Curiosity was selected, and she was invited to go to JPL and to sign the actual rover. And so it's because she named it, her name was selected. And you can see that they have her and everyone else all in their clean room outfits, essentially. And one of the problems before was that with proving life on Mars, there was the fragment, the meteorite fragment, ALH. And that, of course, was discovered here on Earth, and people looked at it and they said that there are the chemical signatures that indicate that that what we're seeing here was in fact bacterial life. And so one of the main objectives is to have a way for the rovers to collect and return a sample of the soil. But before we can get to that, and they've been promising that they were going to be doing the soil return. We'll do the soil return on this one. Well, no, maybe we'll do the soil return on the next mission. So they keep pushing it back. So I can attest to the fact that I'm getting a little frustrated with it myself, and maybe some other people are as well. But what they're basically doing now is they're using different types of spectrometry, and that is basically bouncing a light source onto a rock sample, and you can see the rover doing that here in a simulation. And then based on the types of things that are bounced back, they can tell what the chemical signatures are in the rock. They're also going to be doing other chemical tests where they're doing actual soil samples where they're picking up pieces of the soil. And there's a nice video available that you can watch about that.
It's interesting that those things from Mars that came looked just like that and had the ray. And,
Right. Well, the thing is, too, is like some of this to me seems very subjective. So, for example, like with the rock, it's sort of like it's a hypothesis that it's true. And then the main reason is because they say it might be terrestrial contamination, but if it isn't terrestrial contamination, we'll find it elsewhere. We'll find examples of that elsewhere on Mars, and then we know if we find it on Mars, then it couldn't possibly have been terrestrial contamination unless in the clean room something went wrong, that we introduced bacteria into the environment. So here you can see some of the some of the developments in terms of what the kind of a close-up look of how they're structuring the wheels, how they're doing the engineering. This particular one, they're looking at an automated obstacle avoidance system in trying to do that, and the fact that these types of rovers can in fact not be just the sole ambassadors to Mars, the sole explorers of Mars, the sole field geologists of Mars, but in fact when humans reach Mars, they can be aiding us just as robots here on Earth do. So they could be doing drilling, they could be doing dangerous or hazardous work for us. Okay, and my videos aren't working because I can't connect to the internet. But as you saw before, I'll just flash back and forth here. This is the rover, this is the animated rover. Okay, this is the actual rover. This is the rover that was modeled in Second Life. And one of the things that sort of piqued my curiosity and others' curiosity is the ability to do engineering in Second Life and testing models. And there are physics engines that you could use to simulate gravity or lack of gravity, as well as movement. You can introduce a lot of factors that can affect the motion of particular objects. Building rockets. In fact, NASA Glenn has an island, and they are having a rocket modeling facility there. Now you have to be careful in Second Life, and this is one of the main things that have come up, is that Second Life is open to the public. And so when you're trying to do R&D research, or you're just experimenting, or you're testing a model that may actually be built, then you run into all these ITAR problems, and so you have to be really careful. So NASA has some closed islands that they do their research on as well. And in particular, Jet Burns, or Charles White is his real name. Jet Burns is his Second Life name. He's particularly interested in using Second Life for engineering, and has actually built a building that NASA is going to build. In Second Life, he built it in Second Life, and then they're going to build it in real life. So it saved a lot of money designing it that way. So it seems that there's a possibility that rovers and other type of equipment can be tested and designed in Second Life. But more importantly, oops, am I going the wrong direction? Okay, there we go. Oh, more importantly, here's another example, expensive computer software system designed to show the path for the rover that the rover will take. And of course, JPL's probably the primary designer of the robotics missions that are for Mars, and then Johnson, I believe, is more involved with the human spaceflight activities. But you can see sort of the idea here is that, I mean, that looks very similar to what you just saw in Second Life. If anything, the Second Life videos called Machinima, it's basically a video screen capture, essentially. And these videos can show the demonstrations just like these videos show. So you see a lot of NASA animations, NASA computerized 3D type examples of how they demonstrate equipment, or how things will work, or how they expect them to work. Here's a model of the Mars Phoenix lander at NASA JPL's island. And that's my avatar and a friend of mine. We're exploring. And here you can see how you can model climate. There have been other organizations like NOAA involved, and they're looking at different climate effects. So they've actually modeled a dust devil. Yes, did you have a question?
Yeah, wait a minute.
Okay, all right, thanks. So one of the main projects was the U.S. Air Force. They have what's called the Mission to Mars, and you actually go on a simulated mission. They use this for training for the Air Force, and using different learning techniques, basically role play and simulation. And of course, terraforming. You can terraform the land in Second Life. In terms of the Mars expedition, I wanted to show a video here. This is an actual video clip of, you put on your NASA spacesuit and you follow the rules that you're supposed to follow, and you actually take this long trip, and your destination is Mars. United Space Alliance, just to give you kind of an idea of who else is in Second Life experimenting, they've modeled the Mars Desert Research Station. And the National Space Society, they've participated in creating commercial moon and Mars bases, and invite people to be volunteers to come into Second Life and to provide some ideas. The Mars Institute, I just spoke with Mark the other day, and he outlined some of his goals for using Second Life to provide a virtual Houghton Mars project. And there's a variety of reasons that he could use it: for education, for outreach, to test as a test bed for ideas. And Spaceport UK, you have a lot of international participation. And of course, the planetarium, a place to explore astronomy and enjoy that. So I hope you enjoyed the presentation, and if you have any questions, I'd be happy to answer them. Thank you.
Very good.